Okay, here's a video on lesson 17, grouping, factoring, and completing the square review. So we're really focusing on all the different types of factoring here. I'm going to start off with a flowchart that we used here in class, and that flowchart is right here. And here's the idea. If we're being asked to factor, the first thing we ask ourselves is there a GCF? If no, we move down here. If yes, we factor the GCF to the front and then move to the next step. Now, how many terms does it have? If it's 4, you use factor by grouping. If it's 3, you ask yourself if there's a coefficient, the A coefficient, is it equal to 1? So what I mean by that is if you have like an x squared, not a 3x squared, right? Not this. If the A coefficient is 1, then we can do A and M factoring, double bubble. If the A coefficient is not 1, then we need to use A times C factoring. That's factoring by grouping. So I'm going to go through one example of each type real quick, because these are all reviews of things that we've done already. And let's start off with example 2. Example 1. Okay. So we want to find the roots of this. I'm going to go down the flowchart exactly the way it is. You should have it written in your notes, so you can refer to it as I'm speaking about it. So first thing we ask ourselves is there a GCF? Yes, there is. There's a 2. So they're all divisible by 2, and I can pull a 2 out to the front. 2, leaving me with x squared plus 5x plus 8. And we can check that by distributing back in. 2 times that is, yep, that's 2x squared. 2 times 5x is 10x. 2 times 8 is, oh, see, look at that. I made a mistake already. We want to make sure that we're being careful, and I think that that check is super important. So this should actually be a plus 4. Now look, distribute in, I got 2x squared and 10x, 2 times 4 is 8. Perfect, okay? So that's how I would, let me see if I can get rid of all those. So that's how I would check to make sure that I'm right. Simple distribution errors come from overconfidence. Now, we have a regular polynomial in here, trinomial. So it's got 3 terms. It's equal to 1 as the first coefficient, so we can use A and M factoring. 2 numbers that add to 5 and multiply to 4. Well, 4 could only be 2 times 2 and 4 times 1, so it's got to be this. So that means that I can double bubble this. It becomes x, and positive 4 and positive 1. Throw 2 in front. They want us to find the roots, so set it equal to 0, and then we get a t-chart. This will be negative 4, and this will be negative 1. Okay, so that was A and M factoring. Oh, that's messy. With the GCF first. That's what that was. Move on to the next one. Factor completely. X squared minus 36. Now, this is one of the examples that doesn't really fit on the chart so much. What you might notice is that x squared is a perfect square. It can be square rooted, and so is 36. So if I double bubble this, I get x, and what's the square root of 36? It's 6 and 6. And difference of 2 squares is what this is called. Always gives us a plus and a minus. That is DOTS. If you didn't believe me for some reason, check this out. If I do x plus 6 and x minus 6 as a box method, I get x squared. Here is 6x. The bottom left is negative 6x, and the bottom right is negative 36. When I go to bring these terms out and add them up, I get x squared. 6x minus 6x just crosses out, and minus 36 comes out. So there, I factored it and I checked it, and they didn't want us to find the roots, just factor it, so that would be my final answer here. Example number 3, find the x-intercepts of this. I'm going to start off first by identifying whether or not there's a GCF, and there is. 24 and 30 are both divisible by 6, so I can pull a 6 out to the front. And x cubed and x squared can both give up some x's. They can give up a maximum of 2. So now let's see, 24 divided by 6 is 4. X cubed, I took out 2 of the x's, so I've got 1 x left. Now 30 divided by 6 is going to be a positive 5. and x squared, and I pulled out both of them, so there are no x's left here. Now let's see. 6x squared times 4x is 24x cubed. Good. And 6x squared times 5 is 30x squared. Okay. I just wanted to make sure that I had this correct. So now the thing is that they want us to find the x-intercepts. Now this is factored completely right now. If it said factored, we would be done. But since they want the x-intercepts, we're going to set it equal to 0. We're going to t-chart it, and we're going to solve both sides. So 4x plus 5 equals 0, and 6x squared equals 0. So in order to solve this, I'm just going to try get each x by itself. So here I've got 6 times x, so I'm going to divide by 6, divide by 6. I get x squared is equal to 0. 0 times 6 is 0. And now I can square root both sides in order to get rid of the square. And what I'm left with is x is equal to plus or minus, and the square root of 0 is 0. And then there is no such thing as positive or negative 0, so we can just write 0. On the left-hand side, the right-hand side, and minus 5 and minus 5, to get rid of that, I get 4x is equal to negative 5, and to get x by itself, we divide by 4 on both sides. X is equal to negative 5 over 4. So those are the two x-intercepts. And if you wanted to know what to call that, that was really just a GCF factoring. Nothing else was necessary for this. For question number 4, find the zeros of this. Now, of course, I'm going to refer to my flowchart. 6x cubed minus 10x squared plus 9x minus 15. Let's see the flowchart. Is there a GCF? First question. They're divisible by 2. No, 9's odd. It's not 2 and it's not 3. No, there's no GCF. So now how many terms does it have? Well, it's got 4. So I guess I'm going to do factor by grouping. So I'm going to group the first two and group the second two. I'm going to pull out a GCF from each group. 6 and 10 are both divisible by 2. X cubed and x squared are both divisible by x squared, leaving me with 3x minus 5. On the right hand side, I can divide both of these by 3, leaving me with 3x minus 5. Now I'm going to take my outside stuff and I'm going to combine them into one bubble of their own, one set of parentheses. So 2x squared plus 3. And then you'll see those duplicate 3x minus 5s that can become one bubble themselves, 3x minus 5. They want us to find the zeros, so this would be factored, but they want us to find the zeros. So we set it equal to 0, and we t-chart. We bring them both down and we solve them for x. So 2x cubed plus 3. Oh no, my goodness, I was thinking that's a little too high. 2x squared. I made an algebraic mistake. Okay, 2x squared plus 3. Yeah, is equal to 0. Now here I'm going to minus 3 minus 3. I get 2x squared, keep doing that, is equal to negative 3. I still have a 2 on the front, so I'm going to divide by 2. So I get x squared is equal to negative 3 over 2. And finally, I square root both sides to cancel out the square. So x is equal to plus or minus the square root of negative 3 over 2. There's nothing else I can do to simplify that for now. On the right-hand side, I get 3x minus 5 equals 0. I add 5 to both sides. I get 3x is equal to 5. And then I divide by 3 to get rid of that times 3 on the front. X is equal to 5 over 3. So those are my three solutions: positive square root of negative 3 over 2, negative square root of negative 3 over 2, and 5/3. Our last example is going to be, oh, and that was grouping, by the way. We wrote that on the flow chart, but this is grouping. And our last example here is find the roots of 2x squared plus 9x minus 11. Now, is there a GCF? No. How many terms does it have? It has 3. Is the first coefficient equal to 1? Is a equal to 1? And no, it's not. So that means that we've got to do a times c factoring, which is factoring by grouping. So here's what we do. A, B, keep hitting that button, and c. A times c is going to be negative 22. Now let's list out some factors of negative 22. It's going to have to be 22 and 1, 11 times 2, and that's actually it. Now one of these is going to have to become negative, right, because it multiplies to negative 22. So let's see. It's got to add to positive 9. So that means the bigger one must be positive, and therefore the smaller one must be the negative. Now which one of these is going to add to positive 9? It's going to be this one. So what I can do is I can split the middle term into 11x minus 2x, and I can bring down the other terms next to it. So let's bring this 2x squared down, and the plus sign. Let's bring down the minus 11. And now I should be able to use factor by grouping on them. So I group the first two, and I group the second two. The first GCF is just going to be the variable x, leaving us with 2x plus 11. And over here it's going to be a negative, because the first term is negative, so it's going to be negative 1. There's nothing else that can come out. So 2x plus 11. Now my outside stuff. Can get combined into 1. Parentheses by itself, so x minus 1. And these double 2x plus 11s can combine into 1. 2x plus 11. Now that's factored completely using grouping, or as we like to call it, a times c factoring. But they want the roots. So we're going to set it equal to 0. We're going to t-chart. This is going to be easy, positive 1. On the right-hand side, we're going to have to actually solve. 2x plus 11 equals 0. Minus 11 on both sides. Our goal being to get x by itself. So 2x equals negative 11. And I can divide by 2 on both sides to get x by itself. Negative 11 over 2. Or negative 5.5. Either one of those is acceptable because we didn't have to round. Okay, so I hope that was helpful. If you need the flowchart, go back to the beginning of the video. Good luck. See you tomorrow.